In this video, we're going to look at structures of ionic solids now. An ionic solid structure is very similar to the structures we saw in our previous videos when we were talking about unit cells. The big difference though, when we were talking about the unit cells originally, we're just talking about one atom or one type of atom. And ionic solids must have multiple types of atoms. They need cations and anions. And so our structures are going to be different depending on what types of cations and anions we have. Now the coordination number here is our number of cation and anion interactions, because remember, in an ionic structure, our positive cation must be interacting with our negative anion. And our structures here are trying to maximize our coordination numbers, our positive negative interactions. Here we have cesium chloride. Our coordination number is 8, and our unit cell is 1 cesium per 1 chlorine. And this looks like a unit cell we've actually seen before in our previous videos. The next type of example structure we're going to look at is for NaCl. And NaCl, here we are dealing with anions or ions of different sizes. Here, chlorine is roughly double the size of sodium. So our structure, our crystal structure, has to accommodate these different sizes. And each sodium must be surrounded by a larger chlorine. So really our coordination number here is limited by the number of chlorines that can physically fit around sodium. And that number is 6. You can see that with the center sodium, 1, 2, 3, 4, 5, 6. Each unit cell here looks kind of big, but it's only 4 sodiums and 4 chlorines in total. Now, zinc sulfide has an even bigger size different than sodium chloride. And here our coordination number is only 4. And this type of structure is called a zinc blende structure, where you have sulfides occupying the lattice site of a face-centered cubic structure. And zinc is occupying 4 of the 8 tetrahedral holes located directly beneath each corner. Now, a tetrahedral hole is the empty space at the center of a tetrahedral arrangement of 4 atoms. So here you can see you have a tetrahedral arrangement. That is what these yellow spheres are making. That's called tetrahedral. And in the center you just have empty space. That's where our zinc goes in. Our zinc is interacting with each sulfide. And we're going to be repeating that pattern with zincs interacting with all our sulfides around this structure. Our next structure that we're going to talk about is calcium fluoride. And these structures happen when your ratio of anion to cation is not 1:1. Therefore, our crystal structures have to accommodate an unequal number of cations and anions. Now, many compounds that have a cation-anion ratio of 1:2 will adopt this fluorite structure that calcium fluoride is showing. Here, our calcium cations are occupying our lattice site of a face-centered cubic structure, and our fluoride anions are occupying our tetrahedral holes, 8 of those that we talked about on the previous slide. Here, these unit structures are getting pretty big. We have 4 calciums and 8 fluoride per unit cell, which matches our 1:2 ratio we see in the actual structure. Now, if you have a cation to anion ratio of 2:1, you get an anti-fluorite structure where basically the cations and the anions just swap places. So it's like this structure, but opposite. That's why we call it anti-fluorite. And that's it for this video. I will see you in the next video.